Hello and welcome to what hopefully will be a series of YouTube videos about mathematical proofs that can be proved through visuals or graphically, alternatively geometrically. I have found that Minecraft can be used fairly well for proving these sorts of things. One such example is what we will be going over in this video. And that's actually this expression right here. If you sum up all the numbers between 1 and n, pick your n, these are positive whole numbers, mind you, and then square them, you'll get the same value as if you had cubed each number individually up to n, and sum those numbers together. Now you can prove this through induction using various methods. You know, just state your base case, add 1, proceed algebraically to prove the expression. However, it was noted by the person teaching me this expression that you could probably come up with a fairly interesting geometric proof of this, where you think of each of these as cubes. And if you do, then you can see that this expression actually flattens out. Ooh, that's Minecraft music. Sorry. That this expression actually flattens out these cubes. And I can prove that by showing you this. So here's our base case. We have 1 squared, or the sum of, if we pick n equals 1, rather, we see 1 squared and 1 cubed. Now that's rather simplistic, but let's move up to our next case, which is n equals 2. Now you can see I picked 2 different colors for the 2 squared cube. Now I did this so that you can see geometrically that as we move over to the flattened object, if you decompose this cube into its 2 sides, the green side and the blue side, you can see these sides laid out right here, flattened out. So one thing that you'll notice, let me just turn down this music a little bit. My apologies, folks. It's quite nice though. I like it. Just a little loud. Okay, so if you notice, you can see these sides decompose. But what I really wanted to bring up, and as I noticed this as I was constructing these, I believe it's 6 base cases, 6, well, not base cases, 6 cases, that the even numbered cases had us decomposing the sides into these separate, I'm not sure how to describe them, separate tendrils, I guess you could say. Whereas these, you can see in n equals 3, it sort of beautifully just slices through the cube and pops them out right here. It's very interesting. You can see here again in n equals 4 in an even number that it slices one of the sides into 2 tendrils, and I just find that quite beautiful. I haven't quite figured out how to express this so that I can prove that it infinitely goes onward as this flattening does, but it is something interesting to note. And as we continue to n equals 5, you see once again the sides over here. Let me show this a little bit more expressively. You can see one side is right there, the black is next, and then blue, and then red, and then purple. And it just decomposes beautifully into these little squares instead of the cubes. It's very interesting. And n equals 6. Now, I did create I found out recently, not the largest with these particular blocks, but one smaller than the largest expression, which is n equals 13. with these light up blocks. So let's move through this portal and I can show you. Okay, so this is n equals 14. If you add up all 13 of these cubes, you will come to this large square. Took quite a while to lay all these blocks, but I did it a little differently for this one. I just kept these as red, and I didn't express it on the cube over there. But if I rise above here, you will see 13, because this is n equals 13. You will see 13 slices of that 13 by 13 cube over there, which I will show you in a moment. You'll see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 slices of a 13 by 13 cube. It's a very beautiful proof, I think. And I think for those of you interested in mathematics, as I am, it's very interesting to see kind of laid out like that. So yeah, here's our 13 by 13 cube, and if I had had enough colors and enough patience, I would have changed all the colors to those cubes and changed these as I did with the other ones in the other portion of this proof, and changed all these. But you can see right here that this is a 13 by 13 cube. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm not going to count down. You can just trust me, or count it yourself. And yeah, so it's very interesting, very interesting. If you have any questions, put them in the comments. If you have any other proofs you'd like to see done in Minecraft, anything you mathematicians out there might find interesting, or see maybe for your class you could show something like this. And you know, if you do one of these yourself, please also post it in the comments as a video response. I'd love to see it. So thank you very much. This has been Playmer doing a proof of that expression I showed you earlier. I don't have it here in this portion. So anyway, thank you very much, and have a great night. Be scientific, I guess.